Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, you've come to the right spot, so go ahead and hit the subscribe button. That said, let's get into the current video. I'm going to do an integration by parts example, and I think it's a fairly interesting example because initially it does not look like integration by parts even applies. The specific example I want to take a look at is the integral of cosine of the natural log of x. Okay. Now again, integration by parts has one main requirement, that I've got a product, and may or may not have a composition. Sometimes compositions you can still use integration by parts, but generally speaking I need a product. Well, here I've got a composition, and it doesn't really look like I could choose a natural u and a dv for my integration by parts formatting. So let me go ahead. First of all, I'm going to do a change of variables. So I'll say solution. We're going to start by doing a change of variables. In other words, a u sub. Okay. And what I'm going to do, remember when you do a u substitution, the choice for u is always going to be the inside of the composition. So therefore I'm going to say u is going to be the natural log of x. And then when I do that for a u substitution, u is going to be the inside of the composition, and then just everything follows from that, right? Your du, your limits of integration, if it was a definite integral, so on and so forth. Therefore, du would be 1 over x dx. Okay. If I look at this integral, of course I've got my choice of u is the inside, so I have a cosine of u. My dx, though, I don't have a 1 over x to pair with my dx. Therefore, what I'm going to do is I'm going to rewrite the original integral as follows. I'm going to write this as x cosine of log x all over x dx. So what I have now is log x, of course, is u once again, and then 1 over x dx, that's going to be my du. But remember, if I'm doing a u sub, everything that's related to that integral, the integrand, the differential, limits of integration, if there are any, have to be related to my new variable. I have everything accounted for except for this x right here. But I can easily turn this into an expression that relates to the variable u, because remember that u equals the natural log of x is equivalent to saying x is equal to e to the u. Okay. So therefore, I'm going to replace this x with e to the u, this log with u. Dx over x is going to be my du. Therefore, my integral with respect to the variable u is e to the u cosine of u du. Okay. And depending on where you are in your Calc 2 course, you may have seen the work for this particular integral. This is a favorite of professors because it employs a fairly unique method within integration by parts. If you haven't seen it, I'm going to go through and run through all the work. If you have seen it, feel free to fast forward to the end of the video where I kind of wrap things up. But I'm going to go through the work for actually computing this particular integral. All right, so let's start with integral of e to the u cosine of u du. Now notice this does have a product, and therefore we can try integration by parts with it. Let's go ahead and set up my integration by parts table. U, and then dv, and du, and v. So remember that the u and the dv are the choices that I make. du and v are then going to be a result of those choices. Not only that, I want to have the product of v and du to be the simplest integral that I can make, because the whole point of an integration technique is to convert a complicated integral to a simpler one. And so let's just kind of, before I even write things, if I make this an e to the u, this will also be an e to the u. If I make this an e to the u, so is this. So it doesn't really seem like that provides any motivation to make the bottom product here any simpler. If I make this a cosine, then this would be a negative sign. If I make this a cosine, then this would be a positive sign. Once again, whether it's cosine is here or here, it's still going to be within that product. And so that doesn't really provide me with any motivation for which one should be cosine or e to the u. So therefore, it really doesn't matter in this particular case. What I'll then do is I'll just say u is e to the u, and dv is going to be cosine of u du. Result of those choices then, du would be e to the u du, v would be sine of u. Okay, and then remember, when we do the integration by parts formula, I multiply these two together. So I'll draw this arrow and say multiply, and then I go and take this product and we are going to integrate. Okay, so multiply this product, integrate this product. Okay, so what that gives me is e to the u sine of u minus the integral of e to the u sine of u du. Okay. And did we come up with a simpler integral? Not really. I mean, e to the u cosine u versus e to the u sine u. It's kind of the same thing as far as difficulty. So now what? Well, I'm just going to keep plowing forward, and I'm going to do integration by parts again. And so if I do an integration by parts table on this one, u is going to still be e to the u, and then du is going to be e to the u du, dv would be sine of u du, and v would then be negative cosine of u. And let's just hope something works out here, and it will. Okay, so I'm going to go ahead then and use the integration by parts table for this integral. So don't forget to carry this negative along and have a negative for the entire expression. But this would be e to the u sine of u minus, and let's group this together with a large square bracket. I would have e to the u times negative cosine u, so in other words, negative e to the u cosine of u, and then minus the integral of negative e to the u cosine of u du. And, well, what happened? Of course, negative and negative, I can make that a positive, and same thing with this negative here. If I distribute that through, so this would give me e to the u sine of u plus e to the u cosine of u plus integral of e to the u cosine of u du. Actually, that's going to be negative, 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 so that makes that a negative. All right, and then, no, I'm not going to do integration by parts again, right? The idea is that I started with this integral on top. Okay, so this is equal to dot, 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 dot. So notice that this original integral is equal to this line down here. Well, ultimately, I'm trying to compute that integral. Said differently, I'm trying to solve for that integral. So what I can then do is I could just add this, like it's an unknown, add that to the other side. And let me see, I'd like to be able to keep a variety. I want to keep the original integral up here. I'd like to be able to keep my original substitution. Let me go ahead and start right here. Okay, so what that gives me, if I add that integral to the other side, I'm going to get twice the integral of e to the u cosine of u du is equal to e to the u sine u plus e to the u cosine of u. And of course, there's going to be an arbitrary constant of integration that I'll throw on at the end. But the idea is all I have to do now is divide by 2, and I get the integral of e to the u cosine of u du is e to the u sine u plus e to the u cosine of u divided by 2. And since this is an indefinite integral, I also have a plus c on the end. Okay. All right, am I done? No, because remember the original integral was with respect to x, so I do have to change this so I have the variable x. I'll go ahead and I can clean this side up. And therefore, here's what I have from the very beginning. We were looking at the integral of cosine of the log x dx. And we found that it was equal to this expression right here, where u is the natural log. What I'll then do is I'll back substitute and make this e to the natural log of x sine of the natural log of x plus e to the natural log cosine of the natural log all over 2 plus an arbitrary constant. And the only thing that I can really clean up here is e and the natural log. The natural exponential, the natural log, of course, are inverse functions. And so their composition reduces to the input, giving me x for both of these coefficients here in front of the sine terms, or sine and the cosine terms. So I get x sine log x plus x cosine log x all over 2, and then plus my arbitrary constant. Okay. Thank you for watching, and please consider subscribing.